Hello, ladies and gentlemen. It's Mr. Green again, and this is another in the series of Algebra 2 topics that we're going to be talking about. We're in Chapter 3. We're talking about functions, and we've been talking about operations of functions. And today we're going to take up a different type of an operation. Last time we talked about adding, subtracting, multiplying, and dividing. That didn't seem that difficult. But now we're going to talk about the composition of two functions and evaluate that composition of the two functions. Composition is slightly different, so you need to pay attention to the way that I'm writing this down and what's going to happen. A composition function is a mapping in which each element of the range of one function is the domain of another function. What? Well, what we're going to do is we're going to take two functions. We're going to write it down like this. We're going to say f o g of a number x here. Okay? And what we're going to do is we're going to evaluate g of x and put that in for f of x. So what you're doing is you're getting g of x, which means you're getting the y values of this. So you're getting g of x. And you're going to stick that in to whatever the x value is over here in the f function. And it's going to give you a combined combination of the two functions called a composition. Okay? So, it's giving you a bit of information up here you need to see. The domain of the combination is the set of the domain values of g of x whose range values are in f of x. Wow. A little bit complicated. We'll look at the functions when we get over there and see what we come up with. Okay? So let's look at this. If we let f of x be x squared plus 2 and g of x be 5x, and they're asking us to find f o g, fog of x, okay, the combination thereof. So what I'm going to do is I'm going to say, well, g of x equals 5x. So that means that f of 5x is the way we're going to look at this. So we're sticking that in. So if my f of x is x squared, that means I'm going to come along and say 5x squared plus 2. And that's going to be 25x squared plus 2. That is the FOG of x. So can we go the other way around? Can we say GOF of x? Why, sure. Well, what is f of x? F of x is x squared plus 2. So I want to take g of that. So I want to say g of x squared plus 2. Well, g of x is really 5 times that, so that's going to be equal to 5x squared plus 10. Can you see these are not the same? Not in any way, shape, or form the same. It is just a different way of combining these two together. Okay? So let's look at another one. G of f of x. Wow, now we're getting really complicated. So what we're going to do is we're going to say f of x equals x squared plus 2. So f of x is going to be equal to x squared plus 2 quantity squared plus 2. Well, I got that. Okay, so g of f of x, yeah, is going to be equal to 5x squared plus 2 squared plus 10. Wow, that is ugly, 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 ugly. But that's the way you're combining them together. Let's look at this one, g of x. Wow, okay. So what are we going to do there? We're going to say, well, g of x equals 5x. So g of x is going to be equal to 5 times 5x. And g of x is going to be equal to 5 times 5 times 5x. Well, 5 times 5 is 25 times 5 is 125. That'd be 125. 125x. That's all there is to it. It's just putting one inside of the other one inside of the other one. It's the way it amounts to. Okay? If I wanted to evaluate it for a given value, for 0, this actually becomes easier because I can say, well, what's g of 0? Well, that's going to be 0 minus 7, so that's going to be equal to a negative 7. So f of negative 7 is what I'm looking for. And f of negative 7 is going to be 3 times negative 7 minus 5. That's negative 21 minus 5. That's negative 26. Okay, that didn't seem that difficult. Let's try this over here for 15. So g of 15 is going to be equal to 15 minus 7. That's 8. Sorry, had to cough. Stop the recording for a second. So now I'm finding g of 8, which is going to be equal to 8 minus 7, which is going to be equal to g of 15. G of 15 is going to be equal to 1. Okay, that actually does seem a little bit easier, Mr. Green. I wonder if it works for every time. Try this one. F of negative 3. What I'm going to do is I'm going to find g of negative 3 to begin with. So that means 4 times negative 3 plus 5. That's negative 12 plus 5. That's negative 7. So I'm going to find f of negative 7, and that's going to be equal to negative 7 squared, and that's going to be equal to 49. Let's find this one over here. F of 3 is going to be equal to 3 squared, which is equal to 9. So that means I'm finding g of 9, which is going to be equal to 4 times 9 plus 5. Well, 4 times 9 is 36 plus 5 is 41. And that will be equal to GOF of 3. And this one was equal to FOG of negative 3. That is the way you find the composition. Okay? So let's look at finding the domain and range of different compositions. If we're looking at the f of x equal to this 2 to the x power, and g of x is equal to 1 over x, wow, how do I find f o g of x? Well, if you look at this, it's going to be equal to f of 1 over x. That's going to be equal to 2 to the 1 over x power. Yucky, yucky, yuck, 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 yucky. Well, I can graph this function. And you know what? One of the easy ways is to actually look at the graph and see what you're looking at. So what I'm going to do is I'm going to bring up my handy dandy little calculator here. If it'll work for me just for a second here. Ta-da, handy dandy calculator. And I'm going to clear it out, and I'm going to say press y equals. And I don't want that equation in there. I want 2 raised to the power, which is this little button right there, of parenthesis 1 divided by x, and close parenthesis, and press enter. So I've now got it out there. I can now graph it, and it looks like that. Oh my goodness. Well, you know what? I'm seeing something here that is really interesting. First of all, it looks like that at x equals 0, it doesn't have a value. It looks like it goes off the chart up here to the top that way, and it looks like it doesn't quite get to 0 here on the negative side. Why would it not be equal to 0? Because I can't divide by 0, can I? So when I'm looking at this function right here, 1 over x, I know that my domain can be all real numbers, x not equal to 0. Okay? And that's also expressible by open parenthesis, negative infinity, comma, 0, close parenthesis, union combined with 0, comma, infinity. So it's a combination of those two sets. Now, what about the range? Okay? The range is going to be, well, did it look like it was all real numbers? Let's go back and look at that graph again. Doesn't look like it ever goes down here into the negative side, does it? So I'm going to say all real numbers greater than 0. It's not actually ever equal to 0. Okay? Because you can't ever come up with anything to a power that's equal to 0. So that means it's going to go from open bracket 0 to anything greater than that. So infinity, open bracket. That's the way I would have written the domain and range for this particular function. Now, are there other ways of finding this? Why, sure. The fact that I have something divided by 0 here, well, the range, we know immediately the domain on this one won't be acceptable. That's why we're excluding it from the domain of the entire function, the FOG. Okay? And why would my range only start at 0? Because this is a positive, raised to a positive power here. I'm never going to get anything that's going to be negative. 2 to the x never is a negative number, and it's never going to be equal to 0. So that's where it's coming from. Remember, guys, a lot of courses, make certain you give me the fact that you're in Algebra 2. If you're having any problems with these combined composition functions, make certain you ask questions in the TOGA sessions, because we will try to help you with them, okay? Great. It's good talking to you, and I'll see you next class time.